In this video, we're going to discover how to use the quadratic formula to find the roots of an equation. In one of our earlier videos, we discussed that the roots of an equation basically were our curve crosses the x-axis. Now, in most courses, we're given the formula for the quadratic formula. And if we are starting off with our quadratic formula being the form ax squared plus bx plus c equals 0, we can discover that x is equal to negative b plus or minus the square root of b squared minus 4ac all upon 2a. Now, in the previous video, what we looked at was how to factorise the equation first and use that to find the roots of an equation. This method, however, helps us if we don't know how to factorise that particular equation. Let's say that they are really difficult numbers and we can't necessarily work out what's going on. So let's just cut straight to the chase. Find the roots of the quadratic equation x squared plus 3x plus 2 equals 0 via, first of all, factorising, and then second method via the quadratic formula. Well, via factorising, this is a trinomial, and we know first and foremost that trinomials, we need two pairs of brackets. So two values rather, the times together to give you x squared are x and x. And we need to have two numbers that times together to give you 2, which add together to give you positive 3. Well, two numbers that times together to give you 2 are 2 and 1. They also add together to give you 3. And we want a positive 3, so that must be positive 2 and positive 1. And from earlier we discovered that if we've got two values times together to give you 0, either this value here has to be 0 or this value here has to be 0. So we can make our either or statement, either x plus 2 equals 0 or x plus 1 equals 0, which means x is equal to negative 2 or x is equal to negative 1. And that means if we were to go back to this graph up here, we've got a point at negative 1 and a point at negative 2, not to scale of course. That just shows us exactly where it's crossing the axis. And now I want to prove that this works with the quadratic formula as well. Now, we were told before, we've given the quadratic equation in the form ax squared plus bx plus c. So we're going to look at the coefficients of each of these three terms, and we're going to write them down first of all. So I'm going to tell you that a is equal to 1. Just because there's not a number in there doesn't mean it says there's nothing existing. Remember, in algebra, if we've got an x squared on its own, that is shorthand for saying 1x squared. So a equals 1. We know that b, therefore, is equal to 3, and c is equal to 2. From here, we write our formula out. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And with lots of practice, you won't even need this to be on any formula sheet. You'll end up just being able to write this straight from memory. But x is equal to, so b is 3, so this is going to become minus 3 plus or minus the square root of 3 squared minus 4 times 1 times 2 all over 2 times 1. And now we start battering our way through this. We've got minus 3 plus or minus square root of 3 squared is 9 minus 4 times 1 times 2 is 8 and 2 times 1 is 2. Sorry, there we go. Okay, so that's minus 3 plus or minus square root of 1 over 2. Now at this point here, we've got this plus or minus here, which means we can make a similar either or statement, but involving the quadratic formula. We can say that either x is equal to minus 3 plus root 1 all upon 2, or x is equal to minus 3 minus the square root of 1 all upon 2. So root 1 is just 1, so minus 3 plus 1 upon 2, or minus 3 minus 1 upon 2. We don't even need a calculator for this one. Minus 3 plus 1 is negative 2 upon 2, which means x is minus 1. Or x equals minus 3 minus 1 is minus 4 upon 2, so x equals negative 2. So you notice that we end up with the exact same roots as we did for our factorising. Now, I know what you're thinking. This is a very, very long method to do the exact same thing, but remember, this is going to help us if we can't factorise our quadratic in the first place. Okay, I'm going to show you an example where this helps. So we've got the second example here, and there's always a clue given to you in any kind of paper as to whether you should be using the quadratic formula or using factorising. Whenever we know for sure it's going to be a quadratic formula question, the clue is giving your answers correct to, and it gives you a certain number of decimal places. This means that there's a good chance that the numbers you're going to try and use will not fit. So, just do the same things again. This time we've now got A is 2, B is 9, and C is negative 1. So we'll write them down first. A is 2, B is 9, and C is negative 1. Right, our formula, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And we'll shove our numbers in. We've got minus 9 plus or minus square root of 9 squared minus 4 times 2 times negative 1. Notice we've got a minus times minus in here, so that's going to end up with a positive on the next line down. We've got 2 times 2 on the bottom there. So we've got minus 9 plus or minus the square root of 81. Minus times minus is plus. 4 times 2 times 1 is 8. All upon 4. So, from here, minus 9 plus or minus the square root, 81 plus 8 is 89 upon 4. And we've now got to the same point as we did in the previous example, being this line here. So what we did next is we made our either or statement. We will do the same here as well. So just to save up, leave it a space. Either x is equal to minus 9 plus root 89 all upon 4, or x equals minus 9 minus the square root of 89 all upon 4. So x equals, now this time we don't know what the square root of 89 is. That is absurd in its own right. We're just going to type this straight into the calculator. So here we go. It doesn't matter how old the calculator is, so long as it's got the ability to have multiple functions on there. So we're wanting to have minus 9 plus root 89, then divide everything by 4. We need a pair of brackets around the top when we're doing this on the calculator. So unless of course you have one of these nice calculators with the fraction button included. So negative 9 plus root 89, close brackets, divide by 4 gives us 0.10849, or x equals, and I'll just change that into a minus 4.60849. And notice I'm giving these as unrounded answers first, just in case we make an error when it comes to our rounding. In this case, the rounding shouldn't be too difficult because we've got zeros as our second decimal place. But it's just basically to highlight that, you know, you send to your exam that I know what I'm doing with this, okay? So 1 decimal place, 0.1, 0 rounds down, 0.1, or minus 4.6. And that means that our graph, I should be using a ruler, it's just a rough sketch, y and x, we've got a root at x equals negative 4.6, and we've got one at 0.1. And there you have it. So there'll be a few more examples put up for you on the PowerPoint, but for now, thanks for watching.